eventually become useful. If you do go some sort of path in that direction, like computer science path, or if you're doing, sometimes it, depending on where you're going, some engineering, and definitely if you major in math, you would have to take a class called linear algebra, which is really just all matrices, which is kind of cool. I had to have it in college, and I enjoyed it a lot. I thought it was pretty neat. But this is all can be sort of applied. Now, we're just like learning the very baby steps of it, so it's not going to seem all that useful for us. But especially as like data science becomes such a big thing, like with big data, you know, like they're, you know, spying on us every moment to take data points of our lives to know exactly what we want and influence everything about us. So, so if you like taking that data and doing something with it, matrices really come into play with that. So, a matrix is just an array of numbers or symbols arranged in rows or columns. It's really just like a chart, like a table, really, is what a matrix is. So, like, this is an example of what a matrix would look like. We put these brackets around the edges of them. The first thing we're going to learn about is the order of a matrix. The order of a matrix is the number of rows times the number of columns. So, for example, the matrix below has an order of. The rows always come first. Rows go across. So, like, here's row 1, row 2, row 3. So, we've got 3 rows. So, our order, first number would be 3. And this would be column 1, column 2, column 3, column 4. So, rows and columns. Rows always come first, columns always come second. To help remember that, my teachers would tell us to think of RC Cola, which was even old back when they told me that. Like, I think, do they still make it? I think they still make it. Yeah. Yeah. It's, you know, it was definitely a big thing at the time, but even whenever they were telling me about it, I was like, that is not a normal soft drink. So, but RC Cola, R for rows, C for columns. Rows always come first, so I'll help you keep it straight. This one just asks us to give the order of each matrix. I'm going to give you a second. Put all the order of all those matrices there. Okay. So, let's see. Ethan, what is the order of the first one? 2 times 3. Very good. Let's see. Anaya, what about the second one? 2 by 2. Tyler, how about the third one? 4 by 1. And Alyssa, what about that last one? 4 by 3. All right, so this is going to become very important, especially when we get to multiplying, because we're going to have to know about the order before we can see if we can even multiply those together. The elements of a matrix, if you see something where you have like A sub 11, right here it's whatever letter they decide to use for the term, it is the row comes first, then the column. So like, for example, this is row 1, column 1. This is row 2, column 1. A12 is row 1, column 2. For that. So sometimes you'll see the elements named this way here. And so like this would be just an example of this here. So like for example, the element A23 would be second row, third column. That would be right here. That would be 1. So you sometimes will see them talk about the elements of the matrix in that way, and that's what they're talking about. Find all of those elements in the matrix above. I'm going to give you a second on that one. right, check with your neighbor and see if you guys are getting the same thing there. And maybe you girls turn around and check with Granger since he's neighborless back there. All right. Here's what I got. All right, here's what I got. See if you guys get the same thing. -2, 1, -6, 3, 2, -4. I may have messed them up, so double check. Is that what you guys are getting? Okay. All right, so let's continue on. We're just getting the basics here. Adding and subtracting matrices is going to be very, very, very simple. In order for you to add or subtract matrices, they must have the same order. So they have to be the same size matrix. You cannot add a 2 by 2 matrix and a 2 by 3 matrix. Here, they have to be the same size. And adding matrices is going to be super simple because you are just going to add the elements that are in the same spot. So, like for example, 4 plus 1 would go here and we get 5, right? 8 plus 0 would go here and we get 8. 3 plus 5 would go here and we get 8. And then 7 plus 2 would be 9 and we would get this. So they wrote the intermediate step right there. Your final answer on this one would be 5, 8, 8, 9 for that. Okay, if it was subtraction in between, we would subtract instead of adding. For that would be the only difference. So, moving on. We are supposed to add these together, and if they are undefined, we are supposed to just write undefined. Although, I don't think I put any here that are undefined. What would make one of these undefined?
Have different orders.
If you had different orders. So, like, for example, if I was trying to add 4, 5, and then this one looked like this, 6, -4 instead, then that wouldn't work. And we put undefined. But that is not the case. So, I'm going to give you guys a second here to do these. I'm going to do them with my screen frozen, and then we'll check and see if we get the same thing for that, too. If you guys will grab your calculator too, I'm going to show you how to do these on the calculator, although except for in cases of having like really big data, I don't usually do these on the calculator because they're so easy to do by hand. Okay, check with your neighbor on that one. See if you guys are getting the same answers. The negatives get a little crazy on these. In fact, I'm gonna put mine up here. Y'all might need to check mine. I may have missed one on mine. See if I got the same thing.
I thought it was a plus.
Same. Okay. If several of us are getting the same, that's a good sign.
I just didn't look at the subtractions.
Yeah.
I thought I was adding it.
Yeah.
It's kind of like instinct to just like start adding.
Yeah. Okay. Let me show you how to do this on the calculator, just so you have experience with it. Again, I would just do these by hand every time. Especially like if you see this on the ACT, if it's just adding or subtracting, you're probably best off just doing it by hand. But in some instances, first of all, multiplying is harder and going to be more helpful to use the calculator for. We're going to do that tomorrow, so you guys will see what I'm talking about there. In instances where you have really large data, it might be helpful to use the calculator so that you don't make simple mistakes with that. Where you haven't typed into the calculator correctly, it should be right. So right above the x to the -1 key, it says matrix in blue right here. So you want to hit the blue button and the x to the -1 key. And that is going to take you to the matrix menu. Everybody there? So blue button, x and -1 key gets us to the matrix menu. The first thing you have to do is you have to enter your matrices. Yours may or may not have anything here because you may have not ever put a matrix in here because we don't usually do this much. So you're going to go over to edit. So you're going to hit the over key twice until edit is highlighted. And then what you're doing is you're putting like a matrix in for A and a matrix in for B. And if we were doing the third one, we could do a matrix for C. Each matrix has a name. So I'm going to go to A first. And I'm going to do, let's do number 2. So what is the order of number 2? 3 by 2. So we'll have 3 by 2 here. And you can tell if you did it right or not because the columns and rows will show up in the right spots here. Yours is probably, I already had a matrix in, so that's probably okay. So you're going to type in your data. So just hit 4. It'll go to the next one, -1, 3, 3, -5, 4, and double check that you have all of your numbers in correctly. So we've got the first matrix entered in. We want to go back and do the same thing for our second matrix. So you're going to go to, just hit second, x and -1 again to get that matrix menu, and go over to edit again. Make sure you don't go back to A, because if you go back to A, you'll replace A, and then you won't have the data in that you need. So you're going to go down to B, or you could use C, D, E, whatever letter you want, but I usually just use the first 2. So for B, I'm going to hit enter. This is also a 3 by 2 matrix. And I'm going to put in my data here for 2. Okay, everybody good there? Okay, so at this point, you just want to press second mode to quit to go back to the main screen. I'm going to clear mine out so it's all fresh and clean there, but technically I don't have to do that. So now, since we've got our matrices entered, we want to tell the calculator to subtract those two. So you're going to go second matrix, and it says names right here. We're going to hit enter, and it'll put our A right there. And then we'll do the minus key, and then we'll do second matrix, go down to B, hit enter. So we've got matrix A minus matrix B, and you'll hit enter, and it will subtract them for you. And I didn't get the same answer. What did I do wrong? Because it's supposed to be 2, isn't it? I bet I typed that second.
I got 10 on my paper, but I think mine shows 2. So
Let's see. Oh, I should have had -4 here. Okay.
How do I go back to that screen?
All right, so to edit it, like if you're not getting the right answer, do second matrix, go over to edit, and then like if you want to fix A, you'll go to A, fix B, go to B. There. I need to type in A minus B again. Now I'm getting the right thing. So check on your neighbors, see if they've got the right thing, and help them fix it if it's not working. Six batteries. Let it sit for a second. Think about what it's done. Seriously. Particularly hateful.
oh my gosh. I feel like I'm going to get a copy of it.
It's like, did yours do something like this before? Somebody's was doing this. It was your calculator might be. It's like none of your it doesn't recognize that you're pressing anything.
Mine did this during the exam. It would not work. It just froze on the graph, and it was.
It needed a good smacking, and it appears to now be working. So yours is about to go. It's on its last leg.
I was trying to graph something and it just quit. It
Yeah.
just never graphed it, and it wouldn't let me get off the graph screen. So I just sat there and got
I know what you may have done. You might, if you hit graph, like let's see, I'm gonna hit window 6. Window, let's see, zoom 6. If you hit graph, if you accidentally hit the enter key like while it's trying to graph it, and it does this over here,
Yes.
it's paused, and especially if it hasn't graphed anything yet, when you hit it, you won't realize you've done it, and it'll just feel like it's quit.
But it wouldn't let me leave it. I had to turn the thing off by going second off.
Yeah, the only way, I think,
And it took me a while to figure out how to do that. So I was just sitting there looking at it.
yeah, let's see if I can get it to do it again. I think, I think the only way it'll let you leave it is if you hit enter again, and it'll unpause it, and then that will work for you. So,
I've never used that again.
the matrix, yeah. Well, you're going to want to use it when we start multiplying, because multiplying is harder. You will, but for adding or subtracting, it's not. I mostly just wanted to show you that it was in here, and where to go to matrix C. So, like when we do start using it for other stuff, we've been there before, and there could be a reason that maybe you wanted to use it. And we're going to do some things that are a little bit harder here in a second. Maybe you want to use it, but probably still not much. So, so the next thing that we're going to look at is scalar multiplication. It is super easy as well. If you have like a number outside, this is called a scalar multiple, because it's sort of like you're scaling up or scaling down, like making things bigger or smaller. If you have a number outside of your matrix, you just like distribute it to every number. You just multiply everything inside of the matrix by 2. So pretty straightforward on how to do that. So for example, for this one right here, I would just multiply every single thing by 6. So it's a good test of your multiplication table skills. But you just multiply, 6 times 7 will give you 42. 6 times 8 will be 48. 6 times -5 gives you -30. 6 times 4 is 24. 6 times 6 is 36. And 6 times -9 will give us -54. So just multiply everything that's in there.
For 2, would you multiply it all by 2/3?
Yep, everything has to be multiplied by 2/3 here, which is a little harder, just because it gave you a fraction. This might be where you are tempted to go use the calculator, particularly if it gets any harder than that. The good news is most of these numbers are divisible by 3. So like when you're doing 9 times 2 over 3, what I do when I'm doing that is I reduce it. The 3 and the 9 can reduce. That makes that a 3. You're going to get 6. And then when you multiply 21 times 2/3, the 3 and the 21 can reduce. You'll get a 7 here. You're going to get 14 in that spot. When you're doing 2/3 times -6, the 6 can reduce. You'll get -4 here. The last one, you got to do 2/3 times 13. That will not reduce. So you're going to get 26 over 3 for that last one.
Can we use that calculator like just to multiply each individual one?
Yeah, and you might find it easier if you go to the matrix. You go over here, edit. This is a 2 by 2. It'll 9, 21, -6, 13, and then if you go back to the main screen, you can do 2/3 times matrix A, and it'll give you that. It will give you decimals instead of fractions, depending on like what scenario you're in, what you need, but it'll give you that answer too. So it might be worth it to multiply if they give you something kind of hard to multiply, because it does do all of them at once for you. But those are scalar multiples. And then what we'll see next is basically just like a combination. Now here is another scenario where it's pretty easy to do these by hand, but especially in this case where we got like 3 problems, maybe you might want to use the calculator for this, right? So like to do this by hand, like for number 1, you would have A, which is 2, -4, 2, 1, 3, -2, minus 2 times B. So that B one would have to be multiplied by 2, which would give us 0, 4, 2, -6, 6, -4. And I didn't leave enough room here. And then you would have to subtract, so you'll get 2, -3, -6, 9, -4, and 2, I believe, for that.
So I guess for 2, the 3 would just distribute into all of them?
You can. What I would do instead is I would add A and B together first. So you're going to have the 3 sort of hanging out front, and I would add these 2 together. So 2 plus 0 would give you 2. 1 plus 2 would give you 3. -4 plus 1 would give you -3. 3 plus negative 3 would be 0. 2 plus 3 would give you 5. And negative 2 and negative 2 would give you negative 4. So I would add them together first, and then you can distribute the 3. So you'll get 6, 9, negative 9, 0, 15, negative 12 for that. But you definitely could multiply both of them by 3 first and then add them together. That would give you the same. There.
You also do 3.
Yep. You guys try 3 on your own. I'm going to freeze my screen while I do number 3. Alright. Here's what I've got. Check and see if I did it right. There's always a chance. I think they should start teaching kids about these whenever they're like little bitty. It would be excellent for making them do multiplication over and over and over again. And it's super, like, there's no reason a small child couldn't understand how to do this, I really don't think. Now, when we get to multiplying, it's a lot harder. But just basic scalar multiples, adding and subtracting, would be good practice. They probably don't want to because if you start putting an application, it's a little too hard. They used to, matrices used to be in Algebra 1. Whenever we taught Algebra 1, I wish that, other than the fact that, like, there's too much in that class to get it done in the semester anyway, if you have to do the semester class, I wish they'd put it back because it was easy and the kids could do it. It was not hard. They didn't have to multiply. They only had to add or subtract, scalar multiple stuff. Stuff we're going to do. Alright, so, one other thing that you will see, this will be like the last thing that we look at, is that sometimes we will have matrix equations. And what this does is it kind of like allows you to solve multiple equations at once. Because what it really is like, and this is an option for solving, we'll do number 9 sort of the long way, and then we'll look at the shorter way to solve. But like what it's really telling you is like you got 3 separate equations. Negative 7 equals x plus 3. 1 equals x minus 1. And negative 14 equals x minus 8. All right, it's just giving you 3 different equations. So like if you want to know for your x matrix is going to be a 3 by 3 matrix, you would just like solve each one of those. So you would like subtract 3 and you'd get negative 10. You'd add 1 here and you'd get 2 there in the middle. You'd add 8 over here and you would get negative 6. So that's sort of like always an option, is to just set up equations for this. For example, like on the next one, I could do 4c plus 0 equals 20 and then solve that. And I could just keep going with all those. But since they're set up with matrices, it might be a little bit faster if we just like do the whole matrix at once. So if we're trying to solve for this matrix C right here, we would need to subtract this matrix. And I'm going to write it out each time, but you know, like I'd probably do this part in my head. 0, -9, -4. So 4 times matrix C would equal 20 minus 0 is 20. -1 minus -9 is going to be like -1 plus 9, which will give us 8. And then 20 minus -4 is like 20 plus 4, which will give us 24 here. Everybody okay there? We're kind of out of the territory of where they should teach small children to do this now. Then what would I need to do next? Divide by 4. So if I divide by 4 here, I'll divide everything by 4 on the inside here, and I will get 5, 2, 6. And that'll be my matrix for this. So it kind of like allows you to solve multiple equations at once. This becomes particularly helpful if you have like large data sets and you need to like you know these different pieces of information and you want to figure out the answer for everything all at once rather than solving, you know, each time.
It's like a bigger regular equation solving.
Right, right. Um, 11 and 12 are a little bit different because they have just pieces missing, right? It's not an entire matrix. So when they mean an entire matrix, they'll use like a capital letter here, and it'll be kind of apparent that it has to be a matrix or else you couldn't add them together anyway. These are matrices just set up, and they've just got pieces missing. So like, for example, here, I would just take the pieces and set up an equation. So like, probably, because you got like x plus 2 needs to equal 10. So it should be 8, right? So some of these are so simple you can do them in your head. But like x plus 2 equals 10. You subtract that 2, you get 8. So x should be 8. And then so that means this now is 8. So y, we're looking at the y part here. Y plus 8 should give us -5, and that is going to be -13. Again, you can write out the equation, but you might be able to do it in your head. And if you can, that's fine. So y plus 8 equals -5, and you will subtract that 8, and y will equal -13. If we're looking at the next one, we've got -4 plus 8 equals x. So what is x going to equal? It's going to be 4. So x equals 4. I'll need to put that right here. Notice I didn't do that spot first because it was going to be x plus y equals 16, and I couldn't solve that, but I could solve the other. And so here we are going to have 4 plus y equals 16. And what's that going to give us? 12. Yeah, so because we got 4 plus y equals 16, we'll subtract 4, and y will equal 12. All of this stuff is stuff like could possibly show up on the ACT that maybe you would not have known how to do it, but it's not too bad to do. So maybe, even though you're not going to have a ton of matrix questions on the ACT, but it is a standard based test. Okay. Now this one is our last one that we're going to do today, and it's a little bit different here as well. We got 3x plus a equals b. and they're asking us to plug these values in. It's similar to what we were doing before, but they're asking you to substitute. So you would have 3x is what we're trying to solve for, so it doesn't get replaced, plus 1, negative 2, 0, 3 equals negative 3, 4, 2, 1. So if I'm trying to solve that, what should I do first? I wouldn't divide by 3 first. I would subtract first. So I'd subtract the 1, 0, negative 2, 3. And I like to do this sometimes with those negatives. I'm going to make it a plus sign and change the sign of everything on the inside to help me keep it straight there. So I'm going to get 3x equals, will be negative 4, 6, 2, and negative 2. There. Everybody good there? Then we would divide by 3. A lot of these are going to stay fractions. The problem with the calculator is it's going to give you decimals. So it depends on what you need for that, like what your answer choices look like.
Like we can use the calculator without having to go all the way.
Yeah, you can. But I would just do negative 4/3 to 2/3, negative 2/3 is the way I would do it there. Now, I realize that we did not do any real application with this. We're going to start with a little bit of application tomorrow when we start multiplying. This would definitely be applicable. Like, let me just give you like a glimpse of something that might be the case. Like, let's say that I had my class and I split you into boys and girls and shirt size, so small, medium, large, and I had, 1, 2, 4, 3, 7, 6, something like that, and those were the t-shirt size for my class. And then maybe Miss Martin over here has boys and girls and small, medium, large, and she's got 0, 4, 5, 1, 7, 3, something like that. Yeah. So if we were like gonna order these t-shirts together, and the boy t-shirts look different than the girl t-shirts, we would add our matrices together, and then we could look at how many we need to order of each size. So it would help us, That's a super simple. We probably could do it without a matrix. But let's say we were doing this for the whole school, and all of the teachers sent us these tables. If we just if it was in a spreadsheet or something, we could set it up where it would add them all together and do it for us rather than us have to add everything by hand. So for large data sets, it becomes very helpful to do adding using matrices. For small data sets, you could just do it yourself by hand, really. But that's an example. When we get to multiplying tomorrow, you guys will see how it could be even more helpful because it's kind of got it makes sense why you would want to use it for that. So that is all I have for you today. I think this is simple enough that we probably don't need to do a lot of practice with it. So we're not going to have an assignment that goes